Alright guys, so we are now on the last function that we're going to review. It is exponential functions. So, how do you know you have an exponential function? If you're looking at your graph, you see a curve here. Notice, while it looks like my line is touching the x-axis, it's actually not. It's coming very, very close to it, but it's never going to cross it, never going to touch it. And exponential function never goes below the x-axis. It never goes into the negative y values. Now, a parent function for my exponential functions, we don't necessarily have a parent function, it's just kind of a basic exponential. Started typing wrong on me. There we go. Alright. Bear with me guys, I'm learning this just as you guys are, how to make these videos. Alright, so parent function y equals 1 times 2 to the x power. Okay, so again, we don't really have a parent function. This just here is kind of like an example function, I would say, of an exponential. Alright, where this right here is your y-intercept. This right here is your common ratio. I know this is exponential because I see my exponent is an x. We've talked about this with linear, it has no exponents. With quadratics, you have a 2 as an exponent. But with exponentials, x is your exponent. Now moving on to our attributes, x-intercepts, we were talking about this before, we never, with an exponential, will cross or touch the x-axis, which means there will be no x-intercepts here for exponential. So we're just going to put none. Y-intercepts, on the other hand, we can have, because we can cross the y-axis, and more than likely you will with an exponential. In this case, I see I'm crossing it here at 1. Again, we still want to write this as a coordinate, so we'll type in 0, 1 as our y-intercept. Now our asymptote, that is that line here across the x-axis, making it to where our line here cannot cross the x-axis. So the asymptote is on the x-axis. But remember, we're not going to put x-axis for our answer here for asymptote. What we're going to put is similar to what we did with axis symmetry, but this is a horizontal line, and it's talking about y values that are equal to 0. Because if I look along this line here, all the y values for every coordinate are all 0. Alright, now let's move on to common ratio. Now, before we actually figure out the common ratio, let's go ahead and come up with some coordinates. So a coordinate that I have is 0, 1. That's 1 right there. That's an easy one. And if I continue, I can see I get 1, 2 as another one. Then I have 2, 4 as the next coordinate. And then 3, 8 would be another one. And that, I think, is about it that we can see on this graph. Alright, so now take a look at these here. Look for a pattern on your y values. How can I get from 1 to 2, 2 to 4, 4 to 8? Notice we can't add the same thing to get from one of these to the next, because 1 plus 1 gives me 2, but 2 plus 1 does not give me 4. So adding would not be my pattern. what would be the pattern here is multiplying. 1 times 2 gives me 2. 2 times 2 gives me 4. 4 times 2 gives me 8. Every single time I am multiplying by 2. And that right there is our common ratio. Alright, let's move on to domain and range. Now, our domain in this case, again, domain is all the possible x values. If I go to the left, I see I have an arrow. If I go to the right, I see I have an arrow. Both of them telling me that no matter where I go left to right, I am going to continue on this graph. So my domain would be all real numbers. Now my range, on the other hand, while I do see an arrow when I go downwards, we have talked about this when we talked about asymptote, that I cannot cross this x-axis. So what that means is that I'm never going to get to this x-axis. I always have to be above it. So my range is going to be y is greater than 0. Now I could also write it like this. 0 is less than y. Again, both of them are exactly the same. The key is having the opening facing the y, telling me y is greater than 0 or y is greater than 0. Alright, some extra notes if we needed to add some stuff in. We could put never crosses x-axis. Curved line. Anything else that you can think of, this would be a perfect spot to go ahead and add it in. Any notes that could help you remember when you have an exponential function. And that's about it.